The goal of the lab was to test Newton's second law by filming an object moving at the same speed in the same direction. The object of my study is a soccer ball rolling across a table. The ball has a diameter of 22 centimeters. The origin is located at the center of the ball in the first frame, and the ball is traveling in the negative x direction. Newton's second law states that the final velocity is equal to the net force on the object divided by its mass times change in time plus the initial velocity. When the net force on an object is zero, the object will travel at a constant velocity. Therefore, since the net force on the ball in the experiment is zero, it should be also traveling at a constant velocity. The experiment was then carried out, and the ball was rolled across the table. Using Tracker, we were able to determine the various positions of the ball. The data was then placed in the table over here with time t and position x. Now that we have the data points, we can determine the initial velocity of the ball. Velocity is defined as change in position over change in time. Therefore, we can use the first two data points to find the initial velocity. In this case, it was negative 0.8919 meters per second. Using all the information gathered, a computer model can now be developed in Python. Under the initial conditions section, the ball's mass can be changed to reflect that of the ball in the experiment, in this case 0.43 kilograms. The ball's position vector can be changed so that the ball begins at the origin, 0, 0, 0. And the ball's velocity can be changed so that the initial velocity is that of the one we just calculated, negative 0.8919 in the negative x direction. Under calculation loop, a constant velocity motion can be predicted. First, the t-value was changed to the last frame in my own video. Then the net force vector was changed to 0, 0, 0. This is because the ball was moving at a constant velocity. Next, we had to insert Newton's second law here so that the velocity could be predicted. Same thing here except for the position. Now when we run Python, we were able to see exactly what the ball should do when traveling at a constant velocity. The data from the experiment and the data from the computer model were then placed on the same position versus time graph in order to compare the results. We can see that the ball did indeed travel at a constant velocity because the slope of the line is constant. The only difference between the computer model and the experimental data is that the ball in the experiment appeared to slow down slightly as time went on. This can be contributed to friction between the ball and the table. That means in the experiment, the net force was not completely zero. In conclusion, the computer and experimental model help show that when the net force is zero, objects travel with constant velocity. The error in the experiment was because of friction, and this can be expected because the ball is rolling across a wooden table. If friction can be discarded and a net force of zero could be reached, the ball would have rolled across the table with a constant velocity, proving Newton's second law.